The objectives for this video are to learn how to recognize the attributes of an appropriately drawn grouped frequency distribution and to learn how to draw conclusions from a grouped frequency distribution. A grouped frequency distribution is a useful tool that organizes a dataset in such a way that allows a reader to draw conclusions about a dataset. The following is an example of a grouped frequency distribution showing the ages of students in a community-sponsored art class. The first column gives us the lower and upper limits for each class. Any student in the class between the ages of 10 and 14 would belong in the first class. Any student between the ages of 15 and 19 would belong in the second class, and so on. The last column in this table provides us with the counts of the number of students in the art class that are within the age limits of each class in the grouped frequency distribution. So the first entry in the frequency column tells us that there are 10 art students between the ages of 10 and 14. The second entry tells us that there are 18 students between the ages of 15 and 19. There are 22 students between the ages of 20 and 24. There are 23 students between the ages of 25 and 29. There are 17 students between the ages of 30 and 34. And there are 8 students between the ages of 35 and 39. The numbers in the middle column are called the class boundaries. These numbers are used to separate the classes so that there are no gaps in the frequency distribution. It is important that a grouped frequency distribution follows certain guidelines in order to be of optimal use. Let's examine the grouped frequency distribution for the ages of students in the art class and see if all of the guidelines are satisfied. There should be between 5 and 20 classes. This grouped frequency distribution contains 6 classes. It is preferable, but not absolutely necessary, that the class width be an odd number. We can subtract the lower class boundary from the upper class boundary for any of these classes and see that the class width is 5. The classes must be mutually exclusive. The classes do not overlap, so that each data value would be accounted for in only one class. The classes must be continuous. Note that the upper class limit for any class other than the last is the same as the lower class limit for the next class. In other words, there is no break in the span of the boundaries from the lower class boundary of the first class to the upper class boundary of the last class. The classes must be exhaustive. We do not have access to the original data set, but in order for this guideline to be met, there would have been no students younger than 10 nor older than 39. The classes must be equal in width. We noted earlier that each class has a width of 5. This grouped frequency distribution can tell us nothing about the talent or skill of the students in the class, but there are some interesting trends in the data set that can be found by analyzing the grouped frequency distribution. We can see that the most frequent class is 25 to 29. This tells us that there are more students between the ages of 25 and 29 than any other age group in the distribution. We also note that the distribution is approximately symmetric. There are 6 classes, with the middle 2 being the most frequent and very close in frequency. Also, the frequencies for the first 2 classes are very close to those of the last 2 classes. In this video, we learned how to recognize the attributes of an appropriately drawn grouped frequency distribution and draw conclusions from a grouped frequency distribution.